Hi, I'm Kate, and I'm with NOAA's National Centers for Environmental Information. I'm also part of our Arctic Action Team, and I'm going to tell you guys about a data map viewer that we've been developing to help support Arctic research and planning. So the Arctic, I think we all know, it's a unique and complex environment, and data collection can be difficult and expensive. It's also a region that's uniquely susceptible to effects from climate change. And if you look at the map here, we can see that it's a circumpolar sea, and it's surrounded by 8 nations, and that would be US, Canada, Russia, Finland, Norway, Sweden, Denmark, and Iceland. So there's a governing body called the Arctic Council that comprises those nations, but also includes 6 indigenous groups and 13 non-Arctic observing nations as well. So that can make collaborative regional management pretty tricky. But nevertheless, the goals of the Council are to make informed database decisions, to promote cooperation and coordination on common Arctic issues, and to also promote the sustainable development and Arctic protections. So to make your database decisions, you need data. NCEIs Archives, are a vast repository of all different sorts of data. We've got climate, weather, geophysics, sea ice data, oceanographic data, and this could be satellite, in situ, other remotely sensed data, and it comes to us from data collected by NOAA and also our partners, and some of these programs have also been running for decades and decades, so it's a lot of data. Our goals are to enable the use and the reuse of this data. So our challenge here in the Arctic and with this viewer that we were developing was how do we make this data from our vast archive more visible and more discoverable and more accessible. So another little piece of background here too, for anyone who hasn't heard, the National Centers for Environmental Information is sort of newly formed, or recently formed, from the former NOAA, 3 NOAA data centers there down at the bottom, the Climate Data Center, Geophysical, and Oceanographic Data Center. And so we're now under one organization in these 2 divisions for Center for Climate and Weather, Center for Coast, Oceans, and Geophysics. And so while we're transitioning to our goal of using shared infrastructure and shared systems, in reality, at this point in time, we're still a collection of very different systems across different geographic locations. And so we're all serving up like different versions and data and map services from different vintages of servers and so on and so forth. So that was another challenge that we were facing here. So we've been working on this pilot project for 2 years with a very small team, and we're working very, very part-time on it. But we have stood up this prototype data viewer. Our first step was to go to our large Arctic Action Team and get advice from them about gather representative data sets from across the archives, and that also represented different types of data so that we could sort of test out ways that we needed to be able to visualize them and different things that we needed to deal with. So what we've ended up with is our data viewer. We've got a polar projected GeoCode map. And so we have the features so that you can select 1 or more layers and juxtapose the different data sets on top of each other and view them that way. Each of the data layers have their own legend. We also have links back to the source data's information pages and data access points too. The image on the lower right there is also showing additional features. You can activate this identify feature so that you can click on a point and retrieve back data values and other information from the underlying services there too. We also wanted to experiment with pulling in some multidimensional data. So on the upper left here, we have data from the Arctic Regional Climatology, their seawater temperature and seawater salinity. And this is based on the World Ocean Atlas product that we have. And so that data is served up either in their climatologies, long-term climatologies in increments of annual, seasonal, or monthly bins. And there are also depths ranging from the surface down to 1,500 meters. So we've incorporated drop-down menus so you can select the exact layer that you want to view. We sort of did the same with this other data set here. That's output from the NOMAD's North American regional reanalysis data. We're showing the ground heat flux parameter right there, but that you can also select the year, the month, and the time increment, because that sort of outputs every 3 hours every day. So you can select exactly what you want to view there and pull that up. So we did encounter a few technical challenges, of course, all related to the fact that we're working with different server types and versions. So there was some customization that had to be done while pulling and ingesting those layers. Also, some of the larger global data sets that we had to clip down to our Arctic footprint so that would just improve the loading performance of the data. And we're also, unfortunately, dependent on the status of remote servers. And sometimes it happens, people are shutting down their servers for maintenance, and that means that we can't ingest that data into our viewer at that point in time. So, and then we also had to reproject some layers, which is not a really big deal, but that is an extra step. And finally, for some of the layers that we were pulling in from the thread servers, they didn't have the cartography defined in that service, and so we had to sort of replicate that. And for situations like that, we've determined the involvement of subject matter experts for having them advise us on how to represent these and to make sure that we are showing like an accurate representation of the data is crucial. So we determined, yes, it's a viable approach for sharing and providing access to our data, because it allows the viewers to visually preview the extent and also the attributes and the underlying data. And it does help people locate data sets, I think, more easily than they would be able to otherwise. But in reality, our efforts are a really small-scale example of data sharing needs for the Arctic research community as a whole. I mentioned the Arctic Council at the beginning, and that's all those nations, but there are literally dozens and dozens of research institutions and consortium that are functioning in the Arctic now, and they're grappling with the same issues. So they want to be able to share the information that they're collecting so that they can better coordinate and collaborate among researchers on their projects. So I guess our ultimate lesson is we're going to continue to provide our data in consumable OGC services so that they can be used by other applications and so that we can more easily make them visible and share them with the outside world. So that's the rest of the team. Jesse Varner and John Cartwright were the ones who did the development of the viewer and all that hard work, and the rest of us provided support and logistics. And that's the URL to the viewer there.
Thank you, Kate.